Okay, so today, quartz fans, we're going to look at a carbon sphere. And I know it's carbon because I can't scratch it with a diamond. Okay? And it makes little squares along on the outside of the thing. And the reason for that is because it's just carbon, and all the little carbon atoms are the same size. So they line up in perfect rows and columns and create what we call planes of cleavage. And so we're going to look at planes of cleavage here. That's what planes of cleavage look like. And they are associated with the rows and columns of the carbon atoms all lined up together. Okay, so these are the flaws inside of diamonds that, like De Beers looks for to make sure that, you get flawless diamonds. And I don't particularly care if they have flaws or not. I think the flaws are just dandy. But then I wasn't planning on wearing this one around my neck either. It's what you call thin film diffraction. And that's because there's a discontinuity along one of those planes of cleavage. You can see some more right there, right? And it's molecular thin. And the atoms just don't line up exactly right. Now, in this particular case, what we're looking at is the junction of the X and Y axis, which creates the Z axis, going right down that little cross there, right in that area. And the planes of cleavage cross each other right there at about a 90-degree angle, sometimes at 72 degrees. And you can see that there, the 72 degrees, one X crossing there. Maybe it's 120. I don't know. I haven't measured it. Maybe it's 120 degrees. Because it's associated with the hexagonal symmetry that is also involved in cubic symmetry. Cubes and hexagons form from spheres all lined up that are all the same size in rows and columns. And it makes squares in one direction and hexagons in another direction from the same things. So that is why people get confused. Call it quartz. Except it's not quartz because quartz can't make 90-degree angles. See that 90-degree angle? And quartz can't do that. Quartz can't make cubes because the bond angle of the silicon is at 144 degrees, which means all the internal angles are also 100, multiples of 144 degrees, like 72 and 36, and it doesn't make cubes. Also, of course, it's only 7 on the Mohs scale of hardness, which means a ruby or a sapphire can scratch it. This stuff here, you can't scratch with a ruby or sapphire. It scratches a ruby or sapphire, but it cannot be scratched by a ruby or sapphire because it's 10 on the Mohs scale of hardness. I don't think that. I didn't make that up. I checked. And I didn't make up the Mohs scale of hardness. Some guy named Mo did about 150 years ago. Maybe his name wasn't even Mo. I don't know. Look it up. Look it up. Moh'S. Mohs. And 10 on the Mohs scale of hardness is not just like an order of magnitude harder than a ruby and sapphire at 9. It's 5 orders of magnitude harder because it's got double covalent bonds. And that means that it's really, really clear and is really, really hard. It is the hardest substance on Earth. And quartz fans, I've been looking for some quartz for years and years and years and years. I haven't found any. I'm sorry, you guys. And I'm not actually crazy. I'm not. I measure things. I didn't read it in a book. Well, I did. I read all the same books that all the people that go, it's quartz, are read. I've been reading them since I was 9 years old on a daily basis, and there are discrepancies. Repeated discrepancies, and until you start measuring it yourself, you don't understand. I measure. I'm a scientist.